Hello everyone, welcome back to the channel. Today in this video we are going to learn about the how your thread execute in Foxjoin block, or you can say how can you execute your all the threads parallelly. So today we are going to see all the threads execution in System Verilog in detail. So if you have any query, so you can contact me on this number, or you can also drop a mail on this mail ID. So let's start the video. Now, what are System Verilog thread? So, System Verilog thread is nothing but a piece of code that gets executed as a separate entity. So, in Verilog, each of your initial and always block are spawned off as separate threads that start running the parallel from zero simulation time. Here, you have Foxjoin block that create a different thread that run in parallel. What I mean to say, suppose let's say you have one container in that multiple processes are going on, and if you are writing Foxjoin kind of thing, so all your thread will execute parallelly. Okay, now let's jump to the next slide. So see different Foxjoin style. So in Verilog we only have the Foxjoin kind of thing, but in System Verilog we also have Foxjoin any and Foxjoin none. Here from this diagram, you can see the clear difference. In Foxjoin, whenever your all the three thread has been executed, in only in that case, you will get out of the Foxjoin block. What I mean to say, if you have three thread and if your all thread has been executed, so only in that case, you will get out of the loop. Whereas in Foxjoin any, if any of your thread will get executed, so you will get out of the loop. And whereas in Foxjoin none, you are not waiting for the execution of any thread. All this thread has been scheduled and you can get out of the block. Okay, so this is the basic difference between your Foxjoin, Foxjoin any and Foxjoin none. We will also see some example so it will more clear to you. Now Foxjoin. So in System Verilog, your Foxjoin provide a parallel, or you can say concurrent thread through Foxjoin construct. So now multiple procedural block can be spawned off at the same time using Foxjoin. There are variations to Foxjoin that allow the main thread to continue executing rest of the statement based on when child thread finish. What I mean to say, let's understand it through example. So suppose here we have one example. Now here you can see we have considered one module and then initial begin block. Now here this display will execute at zero simulation time. So I am marking here that this display is executing at zero simulation time. After that, I have considered one Foxjoin block. So see here we have one Foxjoin block. So Foxjoin block tells us that if our all thread has been executed, then and only then we will get out of the block. So if all this thread will get executed, only in that case we will get out of the block and this statement will be printed. Now see here inside we have total three threads. First one is your thread 1, second one is your begin end, that is thread 2, and keep this in mind, the statement which was there in begin end will execute sequentially only. Okay, so see this three thread will start running parallelly. So this will trigger at 30 unit of time, this will trigger first at 5 unit of time and then 15 unit of time, because it will require 5 unit of time and it require 10 unit of time. So total let me write, this will execute at 30 unit of time, this will execute at 5 unit of time, and 5 plus 10 this will execute at 15 unit of time. See why this happen, because here you have begin end statement. So in begin end all the things or all the process or all the thread will execute sequentially only. Okay, now this thread 3 will also execute parallel, that means it will execute at 20 unit of time. And here see the maximum time the require, so here see the maximum required time to get out of the loop is 30. So this display will execute at the 30 unit of time. So we will get a main thread at 0 seconds. So here you can see the output. We are getting the main thread at 0 unit of time. After that 5 unit of time we are getting thread 2. So here you can see at 5 unit of time we are getting thread 2. And then after at 15 unit of time we are getting thread 2 finished. So here we are getting the thread 2 finished. And after 20 unit of time we are getting thread 3 finished. So here our thread 3 finished. And after 30 unit of time our thread 1 is finishing, and at the same instance of time we will get out of the loop and main thread fork join has been finished. Okay, so this is how your execution of your thread inside the fork join has been done. So let's see the another example so it will be more clear to you. Now here you can see I have considered the nested fork join. What I mean by nested fork join, here we have one fork join and inside the fork join we have another fork join. So let's see the execution of the following statement. So here first of all at 0 unit of time this statement will be executed. After that we will moves inside the fork join. So see here we have one fork join and here we have one fork join. Now in fork join we have already learned all this statement execute parallelly. Okay, so what I mean to say, so this all become your thread, like this all become your thread 1 or single thread for your outside fork join, and this is your thread 2 and this is your thread 3. So you can see here now in thread 1 here this statement will execute at 50 and this statement will execute at 70. Since these two threads are there in fork join block, so they will run parallelly. After that we will go inside the begin end block. So in begin end block, after C here we will end up with the 70 and this begin end block will also start parallelly. So this will start at 10 unit of time and this will start at 110 unit of time, because 10 plus 100, so that means 110. Now our thread 2, so this thread will execute at 5 unit of time, this thread will execute at 15 unit of time. Okay, and this thread will execute at 20 unit of time, and see the maximum time we required to complete the entire thread is 110. So this thread will execute at 110 unit of time. Now let's see the output. So see here first statement will execute at 0 simulation time. So here you can see main thread or fork join is going to start. So this will happen at 0 simulation time. After that at 5 simulation time our thread 2 is being executing, and after that at 10 unit of time our thread 1 2 has been executed. Here you can see, so at 10 unit of time our thread 1 2 has been executed. After that at 15 unit of time our thread 2 finished. Here you can see I have mentioned the timing. So at 15 unit of time thread 2 finished. After that see now this will execute at 20 unit of time. So your thread 3 is finishing at 20 unit of time. So we got that. After that 50 unit of time our thread 1 0, and then 70 unit of time thread 1 1, and after that at 110 thread 1 2 finish. Okay, so after that all the threads has been executed, so we will get out of the block, and at the same instance we are getting main thread fork join has finished. So this is how you can also try different example to see the execution of threads in the fork join block. Okay, if you are getting the things, so just subscribe our channel. Now here you can see fork join any. So fork join any will allow the main thread to resume execution of the further statement that lie after the fork if any of the child thread has been completed. See, this is the hi-fi word. In simple word, what I mean to say, suppose here in a single fork join block you have 3 threads. Okay, so in fork join we have learned that if all the 3 fork has been executed, only in that case we will get out of the loop. But in fork join any, let's say suppose we have fork join any. So fork join any is will tell us that if any of your thread has been executed, you will get out of the loop, and the statement which was there outside the loop, this will get executed first, and the remaining statement will schedule for the current time slot. We will see with an example, so it will be more clear to you. So see here I have also considered one example. Suppose if you have 5 threads that are launched, the main thread will resume execution only when one of the 5 thread finish execution. So once the main thread resume operation, the remaining 4 threads that were launched will continue to run in background. Keep this in mind. They will not you can say disabled. They will run in background. Okay. Now here you can see the example. I have considered one module, and inside that module we have considered one display. So this display will execute at 0 simulation time. I hope you got the idea why it is happening at 0 simulation time, because since here we haven't encountered any delay kind of thing, so this execution will done at 0 simulation time. After that, I have considered one nested fork join any block. So here you can see this is your outside fork join any and this is your inside fork join any. So consider this as an thread 1 and this as an thread 2. Okay. And this is your display. Now see here we are invoking our print method. So what are going to happen? So see your fork join tells you that if any of your thread will get executed, so you will get out of the block, or you can say you will get out of the loop. So see this is your thread 1 and this is your thread 2. Now 10 is your delay, because here you can see in print method or print task we have written time, that is delay. Okay, so this will execute at, you can say, 10 unit of time. So at 10 unit of time this statement or this thread will get executed. So at 10 unit of time this statement has been executed. Now see our one thread has been executed, so you will get out of the block, because fork join any tells us if any of your thread has been executed you will get out of the block. Now see this statement will executed at 10. After that this two will schedule for the future, or you can say in the current time slot. Then after 20 unit of time this will get executed, and after 30 unit of time this will get executed. So this is how the execution of your threads inside the fork join any will work. So here you can see in the output section, so here at 0 unit of time we are getting main thread, that is fork join going to start. After that 10 unit of time thread 2 has been executed, and we are getting out of the fork join block and we have executed main thread, fork join has finished. After that 20 and 30 we are getting thread 1 0 and thread 1 1. See what I want to say here, if you are using fork join any, so if your single thread has been executed, so you will get out of the block, and the thread which was there inside the fork join any block will run in the background. Okay, I hope it is clear to you. Now let's see the fork join none. So your fork join none will allow the main thread to resume execution of the further statement that lies after the fork join, regardless of whether the fork thread has been finished. What I mean to say, suppose see, let's see we have a fork join none block and inside that we have 3 threads. So this will not wait for any of the thread to be executed. All the threads has been run in background and we will get out of the loop. Okay, so it will not wait for any of the thread to get executed. Now let's see with the example, so it will be more clear to you. Now here you can see the example. So here we have considered one initial begin block. So this initial begin block will execute it first at 0 time. Okay, after that see here we have fork join none, and inside the fork join none we have 2 threads. So this is your thread 1, let's say, and this is your thread 2. So see fork join none, and this is your, let's say, thread 2, and this is your thread 3. Okay, or you can consider this is not the thread, but it will get executed firstly. So see like here dollar display, first of all at 0 time unit your dollar display will work. After that we move inside the fork join none block. So your fork join none block will say you will not wait for any of the thread to be finished, you just simply invoke this one, main thread fork join has been finished, because you are not waiting for any of the thread to be occurred, and you are running just all the thread in the background. After that see once the execution of this statement has been done, let's say these are happening at 0 unit of time. Okay, now once the execution of this thread you will get inside the loop. Now here we have begin end. So here in begin end we have fork join none and then display. So here you have one thread for this fork join none, and here you have one thread for this print 10, and after that see now here fork join none, here you will get display like your nested fork join has been finished, because here you will not wait for the execution of inside the thread. So you will get at 0 second nested fork has finished. After that at you can say to 10 second you will get thread 2 finished. At 20 you will get a thread 1 0, and at 30 you will get thread 1 1. Okay, so I hope it is clear to you. See, you can keep this in mind, a very simple statement. In fork join none you will not wait for any of the thread to be executed. You can just jump to the outside statement by scheduling the inside statement to run in the background. Okay. Now disable fork. So see what I mean to say here. Suppose there is a statement inside the foxjoin block and you want to disable some statement. So I don't want to execute all the foxjoin threads and I just want to say if one of my thread will get executed, I want to disable that fork. So I will simply write here disable fork. That will do like if I'm considering here foxjoin any. So foxjoin any will execute a single thread. After that they will execute this one, and by using this one I am disabling the fork. So that means the remaining two threads will not get executed. Okay, now here you can see with the example. So suppose here we have considered one initial begin block, and inside the initial begin block we have foxjoin any. So see our foxjoin any will say us that if any of your thread will executed, you will get out of the loop. So this will get executed at 40 unit of time, this will get executed at 20 unit of time, and this will get executed at 20 plus 50, that is 70 unit of time. Let me mark the timing. So this will get executed at 40 unit of time, this will get executed at 20 unit of time, this will get executed at 70 unit of time. Because see here these two thread inside the begin end, so they will run sequentially. That's why here 20 plus 50, that is 70. Now this will get executed at 60 unit of time. So what I meant to say, see now here you can keep this in mind. This is your single thread, this whole is your single thread, and this is the single thread. Now at 20 unit of time this statement will get executed. So at 20 unit of time this statement will get executed, but still we haven't completed any single thread to be completed finished, or still we haven't finished the single thread completion. So this will executed at 40 unit of time. See this is alone a single thread, so one thread has been executed. Now you will get out of the loop and this statement will get executed at 40 unit of time. After that you are disabling the fork, so the rest thread will not get executed. So you can see in the output here at 20 unit of time we are displaying the 20 unit display statement, and after that we are showing that so 40 unit of display statement. After that foxjoin is done, let's disable fork. So your disable fork will simply disable the threads which are going to occur. Okay, now wait fork. Now wait fork is mainly used to wait until all fork process are over. Okay, so here we are waiting for all process, or you can say all thread to be finished. So here you can see with the example, or let me show you some basic example. So in foxjoin any we are saying that suppose if we have considered foxjoin any, and inside the foxjoin any we have three threads, and after that we have some process, let's say some threads here we have, and before that I have written wait fork. Okay, so see what happened in this case. In foxjoin any, if any of the single thread has been executed, so we will get out of the block. So if your let's say this statement has been executed, we will get out of the block. But here wait fork has been encountered, so it will not going to execute this thread, it will wait for all the thread to be complete. Okay, so this happen in your wait fork. Now let's see the example. So here you can see in initial begin I have considered this thread 1 and this is thread 2. You can say this is quite similar to the previous example. This is thread 3. Now this is also a thread, let's say this is a thread 4. Now here we have considered a wait fork. So what it means? So see this statement will get executed at 40 unit of time, this will executed at 20 unit of time, this will get executed at 70 unit of time, this will get executed at 60 unit of time, and this will get executed. See now foxjoin any will tell us that if any of the thread has been executed, that in their time slot the outside slot has been executed or outside thread has been executed. So see at 40 unit of time our one thread has been executed, so this will execute at 40 unit of time only. Now here you can see in foxjoin any this will execute at 10 unit of time, you can say, or not 10 unit of time, because see like here we have mentioned that begin end. So here in begin end what is going to happen, after 40 unit of time we will get out of the loop, and then this will happen at 50 unit of time and we will get out of the loop. But here we are using wait fork, so it will wait for all the fork to be completed. So this will happen 50 plus 20, that means 70 unit of time. Sorry, because see here 50, then this is parallelly this thread will also executed parallelly, so that means 60. So this will execute at 60 unit of time. After that we will get out of the loop, and this will get executed at 70 unit of time because our entire fork has been executed at 70 unit of time, or you can say our entire thread has been finished at 70 unit of time. So this is how you can also use your wait for example to wait for all the thread to be completed. Okay, so this is all for today's video. If you have any query, so you can contact me on this number or drop a mail on this mail ID. And if you are looking for a personal trainer, so you can contact us. We are also providing the personal training for the VLSI field. So feel free to reach out to